All right, everybody, it's review day for test 4, fall 22. We were told to study fall 21, test 4 for an idea of what our test looks like. So, nice place to start. Multiple choice, questions 1 through 4 down here. Got a bunch of products listed here. We're supposed to choose those for these here. Okay. A through B, E. Oh, there's our choice. Sorry. Yeah, there are the choices. Got it? Good to go. Make sure you sign in the sign-in sheet when you're coming in. It's floating around. Okay, so question 1. We're going to start here and go to product 1. Okay, good. We better draw this thing. S, cyclohex 3-ene 1-ol. Alcohols have the highest priority in this course. Alcohol on 1. Nothing else on 1, I don't think. That's going to be S to start with, and 3-ene 1, 2, 3. There's your double bond. Good to go. Yeah. There's a reaction there I did not talk about. Oh, good, because there's a useful reaction at the top of the screen with phosphorus pentachloride in it. You see it? Phosphorus pentachloride is this chemical right here. Highlighter. What happens to my alcohol stereocenter in step 1? R becomes R, not OH, but RCl. That now has what kind of stereocenter? Take a look. Did the stereocenter stay the same in this reaction, or did it flip? It flipped. So whatever used to be S is now going to be R. It's confusing because there's already there's the S, and now it's R. With a Cl. Sodium azide. My analysis says I have a secondary Rx. Analysis is going to be in purple all the way through. Secondary Rx. That's a Mubarak. Yeah. I got a strong new PP solvent. I'm just using short forms here. That's polar A protic. PA solvent. Polar A protic solvent. Everything there says SN2 for the sodium azide reaction, except for RX, which says I don't know. So step 2. Step 2 is going to become R azide, which looks like this if you're curious. Okay, and the R stereocenter in an SN2 reaction is going to become what? You just did the purple analysis and concluded you're getting an SN2 reaction. The red R stereocenter in an SN2 reaction becomes an S stereocenter that's attached to the azide. Notice I'm not writing anything, I just need to know it's S right now. Step 3. Hydrogen excess and platinum does what to the N3? You don't know this reaction. It's given. It's the first one. Step 3 becomes RNH2. There is no stereochemical information. You're going to have to assume that it stays the same. And that S will still be S. It's an amine. I want to pick an amine that has pretty much the same name as my alcohol, except it's not OL at the end, it'll be amine at the end. And it better have S in its name. So which of those molecules has the double bond between 3 and 4 and the amine on 1 and an S stereocenter? This one, right? Yeah. So IV only. D.
So we put S because on start here it says
Your question was, we picked S for our final answer because we started with S?
Yeah, like, would you call
I don't think that logic's gonna work for any of our other examples. No, it was a case, a reaction by reaction decision. The stereo center had 4 different things happening that made that decision. It wasn't set from the beginning. It was set that we started with S and we used a reaction that flips the stereo center. How do you know that? We were told PCl5 flips the stereo center. Okay, so S became R in the first step. Now you have a carbon with a leaving group. You're going to do your analysis to figure out if it's SN2 or SN1. If it was SN1, you're going to get a 50-50 mixture of products, which is a possible in these choices. If you notice very carefully, you look carefully, yes, an SN1 result would be one of these possibilities. Okay, but R became S in step 2 because step 2 you concluded was an SN2. I'm going to write down SN2 because I didn't write it. Okay, and hydrogen and platinum just takes the N triple NNN and makes it NH2. The reaction's at the nitrogen, it's not at the carbon. Okay, look carefully here. Did carbon change? No. Are there new groups attached that disappear? No. Nitrogen just got booted off, didn't it? That's all. Okay. Now, this next one, this is the reaction I said I would start with today. So I'm going to take this opportunity to do the mechanism for this first step down here to fulfill my obligation from Monday. So, and I'll show you everything that's going on for toluene sulfonyl chloride. I will even draw the molecule mech below. Okay, here's my molecule, and I will even draw the S stereo center this time. It's going to be a H there and an OH there. And I have no idea why that happened. There you go. We're going to react it with TSCl. I could ask you to draw TSCl. Has anybody found a practice exam where I made you do such a thing? I made you draw TSOH last test. It's the same drawing. Replace OH with Cl. End of story. But I would never do that to you on a mechanism question. In a mechanism question, I give you the structure so you know what to do. So chlorine, SOO twice, phenyl. To make it toluene, you put a methyl as far away as possible. That's paratoluene. And pyridine is in there as well. How do you draw pyridine? It's the same as drawing what? Benzene, except one of the corners is not a carbon. It is a nitrogen. There's pyridine. Okay, and when you are done, the thing you need to know is that the stereo center is not affected during this transformation at all. There's no backside attack on the carbon. So whatever stereo center you began with is the stereo center you end with. It's just now a better leaving group. Secondary RX is ROTS, okay? And the other products you're gonna have when it's, you know, the mechanisms on your test would be pyridinium. I don't know why I started drawing everything horizontal. Don't like it. And a chloride off there too. So all the atoms are accounted for there. The mechanism starts like this. Lone pair on O attacks the sulfur that has 5 bonds to more electronegative atoms. And the pi bond breaks. This is the same as the SO2 mechanism we finished with on Monday. Same first step. The SOCl2 is what I should have said. Thionyl chloride, we called it. That would result in this outcome. The stereo center has not been touched. So it stays the same. You now have a sulfur with an O minus. And we have a Cl. And we have a, I'm going to call it R. You can't do that on a test unless you do this as well. I don't want to draw this anymore, Dr. Whitaker. I'm going to call it R. And yes, on mechanisms, you can do that any day of the week. And we got a plus sign on my O. Now, I know we're trying to study real hard. If you look at the mechanism for the one you did on Monday with SOCl2 and pyridine, I did an acid-base step next with the pyridine. In the evening, I did the acid-base, the second step after this one. They are interchangeable. You can do this step next or the next step first. I will do it the opposite way I did it on Monday, just to show you they're both okay. Keep in mind, this reaction has the same start as the SOCl2 pyridine question. Steps 2 and 3 are interchangeable. So you can do the acid base now or later. I did the acid base first on Monday. I'm going to do it second here. Here, the elimination first, and then the acid base. There's a good argument the acid base should be first. Those reactions are typically fast, but I think that's just one step too far. A lot of that keyboard lately. There you go. And we're almost done, aren't we? What's the only thing that needs to be done? I told you this mechanism is a lot easier than the one on Monday. How do you get from there to there? This thing and this thing need to become these two things. Guys, these are almost the same molecule, aren't they? S-double-O twice with the R group, That's not changing. It's an acid-base reaction. What's the base? Pyridine. Put the lone pair on your pyridine. Grab the H. End of story. Most important thing is an S stereo center is still an S stereo center. That is the one thing for this multiple choice we started earlier. Okay? And it's a secondary RX when you're done. Okay. Make sure you sign the sign-in sheet. I believe it is here. Okay, so step 1 here. From here to here, step 1 becomes ROTS, and it's still S. And it's a secondary RX, right? So it's a Mubarif on its own. You're following that with sodium azide and acetone. That's the same as before, right? Strong nucleophile, polar A product solvent, SN2. SN2. So it's going to goes to RN3, which is now, is it S or R? This is a backside attack on the carbon that has the OTS. So it becomes R. Oops, R at the end. S in the beginning. No, SN2 is the, yeah. And all we need to know is what's here. And then hydrogen, guys, it's the same product as the previous one, but it's the other isomer, isn't it? Yeah. Isn't that cool? You started with the same alcohol and you could make either amine. That is powerful right there. I don't know if you can appreciate it, how profound that is right now, but that is a very profound thing. Because in nature, we start our syntheses with molecules we can get cheaply in nature. And often they're alcohols, but often in nature, only one of the alcohol hands is available. The other is far too rare, and you can't start with that. It's just too expensive. So you're forced to start with the one alcohol. It's good to have chemistry that gets me to either option of the amine, right? So it was worth mentioning. Okay? So I'm picking the same answer I picked for the first question, except it is the enantiomer of this, which would be 3 only, right? So did a lot of our thinking, I don't know. And 3 only is C. Okay. Now we're back to our phosphorus pentachloride. So our S is becoming R again. 1, you get RCl. That's S. Or sorry, R, because you started with S. That's correct? Yeah. And then we're doing our water, heat, and a hint, slow SN1. I had to give you this hint because I just tell you right now, even though water is not a strong base, students still think about E2 every time they see heat. That was only half of it. It's heat plus strong base gives E2. Here I'm telling you guys, this reaction was just too darn slow. I had to heat it up to speed it up. And it's not an E2. I'm telling you it's not an E2. It's an SN1. It was slow, so I had to heat it. Okay? All right, so no override. Straight up SN1 analysis. You're told, don't even bother doing the analysis. It's right there. Okay? Then phosphorus pentachloride. Do you remember that during this, you get ROH, that's RS. 50-50 RS. Why? What kind of reaction made it? SN1, SN2, E1, E2, NGP. Which one? SN1. It's written right there. What happens to a stereocenter during an SN1? It gets, yeah, you get 50-50 mix of each. So right now you're at a 50-50 mix of 2 alcohols. And then phosphorus pentachloride is going to give a 50-50 mix of, this was step 2. This was 2. Step 3, RCl, 50-50. And then step 4, 50-50 R-azide, RN3, 50-50. I think you're getting the idea. It's 3 and 4 this time, I hope. And then 3 and 4. 2 amines. We've picked them already. Now you're making both 50-50. So 3 and 4 is choice number 3, 4, 50-50 is BC. Nope, I want that to be blue. Okay. This is fall 21, test 4, part 1, right here. And then, oh, the answer was listed as AE? Uh-oh, I'm sad about that. 1 and 2, 50-50. Yeah. You sure that's not product 4? Yeah. Well, phosphorus pentachloride makes straight up R from S with a Cl. Then the water and this thing did RCl becoming ROH with an SN1. I'm agreeing with that. And then phosphorus pentachloride makes the RCl. We did RCl before. And then RCl backside attack, sodium azide, acetone. Yeah. Hydrogen and platinum. If it was choice AE, then reaction 4 had to be sodium cyanide. That is the mistake on the answer key, by the way. AE is wrong, so we found a mistake. Error on key is corrected here. We're going to see what happens with cyanide soon, because I see sodium cyanide up there. So step one is the same as our step ones we did before. Backside attack on ROH makes RCl, that is now R, is now R. Backside attack with cyanide, because this is also SN2. Strong nucleophile, polar A product solvent, SN2, step 2, gives RCN. Backside attack on an R stereocenter is now what? F. And RCN becomes what with a useful reaction on the middle of the top of the screen? Becomes RCH2, NH2. You want those to be blue? You see those were the new things. And that would be cyclohexanylmethanamine. This here is methanamine. Methanamine. We just have to name the carbon group attached to methanamine. And the S stereocenter stays S because there's no, in the hydrogen does not change the stereocenters, people, ever. There you go. So S stays the same. So we have methanamine with the right R group on it. How many methanamine choices are there? There's 4. Yeah. Oh, wow. Oh, wow. I figured out something finally. AE. Where was that AE? 1, 2, 50, 50. 2 in what I mean? I outduped myself. I've realized in the previous question, I outduped myself. Right here. There was a subtle sly thing in there I totally missed on my own exam. Oh man, and it deserves its own little spiel. It's an important thing I missed. So we're gonna backtrack to that. We'll finish this one first, and we just got to realize what this thing looks like. And I want to draw it. R didn't change the whole day. So moving over everything. I just want to draw RCH2. It's got the double bond down here, right? And it's R, so we can go CH2, NH2, and an H. And 1, 2, 3, 4. So the ene is between 3 and 4. So we're talking about, it's S, correct? And I'm liking this one. Yeah. Shouldn't circle it with that one. And is that correct on the key? And that one. AD. BC is going to go away. I suspect maybe the AE is going to appear. This may not be an error. Deserves its own video. That's how important it is. We're coming back to do product 3. So be ready for that.